Hello, in this lecture we'll find out the area of the green shape using two different methods. In the drawing we have a quarter circle. AOB is a quarter circle. Inside the quarter circle we have quadrilateral ACDO, and we have to find out the area of this quadrilateral, the green quadrilateral ACDO. In addition, we know that side AC of the quadrilateral is equal to 24 units, side CD equals to 7 units, and this angle ACD equals to 90 degrees. Again, our mission is to find out the area of the green shape, the area of quadrilateral ACOD. So we'll start with the first method. AOB is a quarter circle, therefore this angle must be equal to 90 degrees. Point O is the center of the circle that we can create by completing the quarter circle to a circle. Okay, so in the next step, from point O, that is the center of the circle, we will draw perpendicular to chord AC. So this angle equals to 90 degrees, and this angle will also equal to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and chord AC is P. Here we have rule number 11. According to rule number 11, the perpendicular to a chord drawn from the center of the circle bisects the chord. Point O is the center of this circle. From point O, we draw perpendicular to chord AB, that is to say this angle equals to 90 degrees, and this angle equals to 90 degrees according to our construction. So whenever you draw perpendicular towards any chord, here we draw perpendicular OM to chord AB, the perpendicular OM will also bisect chord AB. That is to say AM equals to MB. So if OM is perpendicular to AB, then according to rule number 11, OM also bisects chord AB, that is to say AM equals to MB. Okay, so we can implement rule number 11 in our drawing. Why? Because in our drawing we have from point O, that is the center of the circle, we draw perpendicular towards chord AC. According to rule number 11, perpendicular OP from the center of the circle, that is to say from point O, bisect chord AC. That is to say AP equals to PC. That is to say the perpendicular OP divides AC into two halves. The first half is AP and the second half is AC. And the second half is PC. And because of the fact that AC in total equals to 24, it means that the first half will be 24 over 2, that is 12. So AP will be equal to 12 units in its length. And the second half, PC, will be also equals to 12 units. This is the implementation of rule number 11 in our drawing. In the next step, from point D, we draw perpendicular on PO. So actually, this angle equals to 90 degrees, and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point D in PO is Q. Created here, quadrilateral DQPC. Inside quadrilateral DQPC, we have 1, 2, 3 rectangles. the sum of three right angles is 90 times 3 is 270 degrees, plus the size of the fourth angle. In total, it must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing angle here must be equal to 90 degrees. In order to complete the sum of the angles inside quadrilateral PCDQ to 360 degrees, the missing angle here must be equal to 90 degrees. So I found out that inside quadrilateral QPCD we have four right angles. So we can relate to quadrilateral QPCD as a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. That is to say CD equals to PQ. But CD is 7, therefore PQ must be also equal to 7 units in its length. Likewise, in rectangle PCDQ, PC must be equal to the opposite side QD. But PC is 12, therefore QD must be also equal to 12 units in its length. In the next step, we define the length of 97 QO as X. We focus on the right triangle OQD. In this right triangle OQD, we define angle QDO, this angle as alpha. So in the right triangle QOD, this angle equals to alpha, this angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha, it is 90 degrees, and 90 degrees plus 90 degrees, it is equals to 180 degrees. That is the sum of the angles in any triangle. So this angle equals to 90 degrees minus alpha. We define 90 degrees minus alpha as beta. So we can substitute 90 degrees minus alpha here by beta. So this angle equals to beta. Note that angle AOB, because of the fact that AOB is a quarter circle, angle AOB must be equal to 90 degrees. So AOB is equal to 90 degrees minus angle beta must be equal to the missing angle, angle AOP. So I write it down, the missing angle, angle AOP must be equal to angle AOB that is equal to 90 degrees minus this angle, angle beta. So 90 degrees minus beta, and beta equals to 90 degrees minus alpha, so we can substitute beta here by 90 degrees minus alpha. So what is the value of this expression? We'll open the brackets here, and we'll get that 90 degrees minus 90 degrees is 0, and minus times minus is plus, so in total this expression must be equal to alpha. In conclusion, found out that the missing angle, angle AOP equals to alpha. This is the missing angle, angle AOP is equals to alpha. We will focus on the right triangle AOP. In this right triangle, this angle equals to alpha. This angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus alpha. But 90 degrees minus alpha is beta. So we can substitute 90 degrees minus alpha here by beta. We'll focus on the right triangle OQD. This right triangle OQD, so I'll copy the right triangle OQD in a new page and find out the value of triangles alpha. Okay. Angle QDO equals to alpha. QD equals to 12 units in its length. That's actually QD. And QO equals to X according to our definition. Actually, this is the right triangle QOD that I copied from the original drawing. This angle equals to 90 degrees, of course. Again, QD equals to X according to our definition. It is QO that is equal to X. QD equals to 12 units, and the angle QDO, it is angle alpha, equals to alpha. So in this right triangle, triangle QOD, we get that tangents alpha will be equal to QO over QD. QO equals to X and QD equals to 12. So in conclusion, found out the tangents alpha in the right triangle QOD equals to X over 12. In the next step, we'll focus on the right triangle AOP. So I copy the right triangle APO. This right triangle APO in a new page. We'll find out the value of tangent theta in this right triangle APO. AP equals to 12 units in itself. What is the value of PO? From the drawing it is very easy to see that PO equals to PQ plus QO. That is to say, PO equals to PQ, that is 7, plus QO, that is X. So in total PO equals to X plus 7. Actually, this is the right triangle APO that I copied from the original drawing. AP equals to 12, PO equals to X plus 7, and angle AOP equals to alpha. In this right triangle, triangle APO, we'll get the tangents alpha equals to AP over PO. AP equals to 12 and PO equals to X plus 7. So in conclusion, found out that according to equation number 2, tangents alpha equals to 12 over X plus 7. So we have here two different expressions for tangents alpha. According to equation number 1, tangents alpha equals to X over 12, and while according to equation number 2, tangents alpha equals to 12 over X plus 7. In the next step, we'll create equation number 3. And according to equation number 3, tangents alpha according to equation number 1 must be equal to tangents alpha according to equation number 2. Okay. So tangents alpha according to equation number 1 equals to X over 12. And it must be equal to tangents alpha according to equation number 2. Tangents alpha according to equation number 2 equals to 12 over X plus 7. In conclusion, found out that according to equation number 3, X over 12 equals to 12 over X plus 7. Here we cross multiply this equation and we get that X times X plus 7 equals to 12 times 12, that is 144. Here we will open the brackets of this side of this equation number 3. And we get that x times x is x squared plus 7x equals to 144. We subtract 144 from this equation, and we get that x squared plus 7x minus 144 equals to 0. So we have here a quadratic equation. The general formula for a quadratic equation is ax squared plus bx plus c equals to 0. Here a, b and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. We find out the value of x according to the following formula. X actually equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. Here a, b and c are also the coefficients of the quadratic equation. So in our specific equation, x squared plus 7x equals x squared plus 7x minus 144 equals to 0. The coefficient a equals to 1, the coefficient b equals to 7, and the coefficient c equals to minus 144. Now we have to put the data inside the equation here for x in order to find out the value of x. So x will be equal to minus b. B is 7, so minus b is minus 7, plus minus the square root of b squared. B is 7, so b squared is 7 squared, it is 49, minus 4 times a is 1, times c is minus 144. All divided by 2a. A is 1, so 2 times 1 is 2. So here we found out actually that x equals to minus 7 plus minus square root of, so minus 4 times minus 144 is plus 576 plus 49, in total it is equals to 625. So inside the root we left only with 625 over 2. So here we will get that x equals to minus 7 plus minus the square root of 625 is 25 over 2. So here we found out that x equals to minus 7 plus minus 25 over 2. Here we will have two solutions possible for x. The first solution for x is that x equals to minus 7 minus 25 over 2. Minus 7 minus 25 is minus 32 over 2. Minus 32 over 2 is minus 16. So in conclusion, we found out that x equals, according to the first solution, x equals to minus 16. But because of the fact that x is the length of line 7QO, x as the length, yes, x is the length, and as a length it must be a positive number. So we cancel this solution. X cannot be equal to any negative numbers, and we left only with the second solution that is possible for x. The second solution for x is x equals to minus 7 plus 25 over 2. 25 minus 7 is 18, and 18 over 2 is 9. So we found out that according to the second solution, x equals to 9 units. Here, QO equals to x and x equals to 9. Okay. Our mission is to find out the area of the green shape. That's actually the area of quadrilateral ACDO. We'll divide the green shape into three parts. The first part will be the area and the right triangle APO. The second part will be the area, the right triangle OQD. This will be A2. And finally, the third part of the green shape is the area, the rectangle QPDC. This will be A3. From a drawing, it is very obvious that A1 plus A2 plus A3 equals exactly to the area of the green shape. That is to say, the sum of the areas of the two right triangles plus the area of rectangle PCDQ must be equal to the area of the green shape. So I'll write it down. We actually found out that the area of the green shape equals to the area of the right triangle APO, that is A1, plus the area of the right triangle QOD, that is A2, plus the area of rectangle PCQD, that is A3. Repeat again. From the drawing, it is very clear that the area of the green shape equals to A1 plus A2 plus A3. So A1 is the area of triangle the right triangle APO. So I copy the right triangle APO in a new page and we find out the area of this right triangle. Okay. AP equals to 12 units in Israel. PO equals to PQ plus QO, that is to say PO equals to 7 plus X and X equals to 9, so in total PO equals to 7 plus 9, that is 16. So this is the right triangle APO that I copied from the original drawing. The area of the right triangle APO is the area of A1. So what is the area of this right triangle APO? The area must be equal to the base, that is AP, times the I to the base, that is PO, over 2. AP is 12. PO is 16 over 2. 16 over 2 is 8, and so in total this expression equals to 8 times 12, that is 96 square units. So in conclusion, found out that A1 equals to 96 square units. In the next step, we find out the area of A2. So I already mentioned A2, it is actually the right triangle OQD, so I will copy the right triangle OQD in a new page and we find out the area of this right triangle. OQ equals to X and X equals to 9, of course. QD equals to 12. Again, the area of A2 is the area of the right triangle OQD. This is the right triangle OQD that I copied from the original drawing. The area of this right triangle OQD equals to OQ, that is the base of the triangle, times the height to the base, that is QD, over 2. OQ equals to 9, and QD equals to 12 over 2. 12 over 2 is 6, so in total this expression equals to 6 times 9, that is actually 54. In conclusion, found out that A2 equals to 54 square units, that is actually the area of the right triangle OQD. And finally, we'll find out the area of A3, that is actually the area of rectangle QPCD. The area of any rectangle is the width of the rectangle times the length. The width is QP and the length is PC. So this is QP times PC. QP equals to 7 and the length PC equals to 12. So the area A3 equals to 7 times 12, that is actually 84. In conclusion, found out that A3 equals to 84 square units. That is actually the area of rectangle PCQD. Repeat again, the area of the green shape equals to A1 plus A2 plus A3. The area of the green shape equals to A1 plus A2 plus A3. A1 equals to 96 plus A2 is 54 plus A3 is 84. 96 plus 54 is 115, and 150 plus 83, it is 234 square units. So I actually found out that the area of the green shape in total it is equals to 234 square units. Repeat again, the area of this green shape in total equals to 234 square units. Next step, I present to you how to find out the area of this green shape according to the second method. In the second method, we join points A and D together by a straight line. By joining points A and D, we actually created the right triangle ACD. So we copy the right triangle ACD in the new page, and we will find out the value of the length of the hypotenuse AD. So actually, This is the right triangle ACD that I copied from the original drawing. AC equals to 24, CD equals to 7 units according to what is given us the equation, and we have to find out the length of the hypotenuse AD. By PT is the evaluation for Pythagoras theorem. Yeah. So according to the Pythagoras theorem, in this right triangle, ACD, AD squared must be equal to AC squared plus CD squared. So AD squared, that is the square of the hypotenuse, equals to AC squared. AC is 24, therefore AC squared is 24 squared, that is 576, plus CD squared, CD is 7, therefore CD squared is 7 squared, that is 49. So we're going to find out that AD squared equals to 576 plus 49, it is 625. Here we take out of this equation, and we get that AD equals to the square root of 625, that is 25 units. So the hypotenuse AD equals to 25 units in its length. I'll write it down in the original drawing. The hypotenuse AD equals to 25 units in its length. Angle AOB, because of the fact that AOB is a quarter circle, this angle must be equal to 90 degrees. Again, point O is the center of the circle that can be created by completing the quarter circle to a circle. So we'll complete this quarter circle to a circle. Point O will be the center of the circle that we will create. So we completed the quarter circle to a circle. Point O is the center of this circle. Point A is the point of the circle itself. Therefore, OA is the radius of this circle. We will define the radius of this circle as R. So OA equals to R. We will extend the radius AO by a straight line until it touches the circle. And we will define the touching point of the extended radius AO and the circle as M. AM is a chord inside this circle. Chord AM passes through point O, that is the center of this circle, and any chord that passes through the center of the circle must be the diameter of the circle. Therefore, AM is the diameter of the circle. AM is the diameter of the circle. Point O is the center of the circle, point M is the point of the circle itself, therefore OM is the radius of this circle that is equal to R. And you can see that AM in total equals to R plus R, that is 2R. It is the length of any diameter. It is always times as long as the radius. In the next step, we will extend side CD by a straight line until it touches the circle. So we don't know where the extended side CD will touch the circle. So we will assume that the extended side CD will not touch the circle exactly at point M, but at another point. It's actually this point at point N. Okay, but again, we assume that the extended side CD will touch the circle at point N and not at point M. And therefore we will have peripheral angle ACN. This peripheral angle ACN equals to 90 degrees. It is given as the equation. Because angle ACD equals to 90 degrees, therefore the peripheral angle ACN must be equal also to 90 degrees. But according to rule number 5, it is not possible. Why? Because according to rule number 5, any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. Here we have peripheral angle MAN that is equal to 90 degrees. This peripheral angle MAN rests on NM, that is the diameter of this circle. And here we found out that this peripheral angle ACN that is equal to 90 degrees doesn't rest on AM, that is the diameter of the circle, but rests on chord AN that is not the diameter. This contradicts rule number 5. According to rule number 5, this peripheral angle AC, after we will extend it, it will be AC whatever, it is equal to 90 degrees. This peripheral angle equals to 90 degrees, therefore it must rest on AM. If peripheral angle ACM rests on AM, it means that the extended side CD must touch the circle exactly at point M and not in any other point. Okay. Now we have peripheral angle ACM that is equal to 90 degrees, and it obeys rule number 5. Why? Because this peripheral angle ACM that is equal to 90 degrees indeed rests on AM, that is the diameter of the circle, exactly according to rule number 5. Therefore, when we extended side CD by a straight line, it must touch the circle at point M and not in any other point. Actually here, CDM, it is one straight line. It is not clear from the drawing itself, but here CDM must be one straight line, because when we extend side CD by a straight line, it must touch the circle at point M and not in any other point. Okay, so ignore the drawing itself, but we actually know that according to rule number 5, the extended side CD must touch the circle at point M, therefore CDM is one straight line. Okay. In the next step, we'll focus on this side of the diameter AM at point O. Which angles we have at this side of AM at point O? We have this angle that is equal to 90 degrees plus the missing angle. In total it must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So the missing angle here must be equal to 90 degrees. Repeat again, the missing angle here must be equal to 90 degrees according to the rule that I mentioned. In the next step, we'll prove that the right triangle ADO is congruent to the right triangle ODM. Okay, so let's down the right triangle AOD is congruent to the right triangle ODM. So why those two right triangles can go into each other? First of all, side AO of the green triangle equals to side OM of this triangle. Why? Because they are, both sides are the radii of this circle and therefore they are equal to each other. So I write it down. AO equals to OM. Again, side AO equals to side OM. They are both the radii of the circle, therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees, therefore they are equal to each other. So angle AOD of the green triangle is equals to angle MOD of this triangle. Repeat again. Angle AOD equals to angle MOD. They are both equal to 90 degrees, therefore they are equal to each other. And finally, OD, side OD, is a common side that belongs to both triangles. So I can write down that OD equals to itself as a common side that belongs to both triangles. OD equals to itself, it's a common side that belongs to both triangles. So actually prove that those two triangles can go into each other according to side angle side rule. We have two sides and the angle between them in this triangle are corresponding equal to those two sides and the angle between them in the green triangle. So write it down. The green triangle AOD is congruent. This is the sign of congruent to the other right triangle, triangle ODM, according to side angle side rule. And from the fact that those two right triangles can go into each other, we derive from it that side AD of the green triangle must equal to side DM of the white triangle. AD equals to DM. Repeat again. AD equals to DM according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles can go into each other, therefore the corresponding sides AD and DM must be equal to each other. But we have already found out that AD equals to 25. So we can write here that AD equals to 25. And from this equation 25 equals to AD equals to DM, we will derive that DM is also equals to 25. Here this side DM equals to 25 units in its length. As I already mentioned before, ignore the drawing itself. CDM is one straight line, and therefore CM in total must be equal to CD plus dm. CD is 7, dm is 25, so in total cm will be equal to 7 plus 25, that is 32. In the next step, I will copy the right triangle ACM in a new page, and we will implement in this right triangle ACM, the Pythagoras theorem. Again, CM equals to 32 units in its length, AC equals to 24 units in its length, and the hypotenuse to AM equals to 2R. Okay, so I copy this right triangle ACM, a new page. So actually, this is the right triangle ACM that I copied from the original drawing, and I repeat again that CM equals to 32, AC equals to 24, and AM, the hypotenuse AM equals to 2R. We'll implement here the Pythagoras theorem by PT version for Pythagoras theorem. According to the Pythagoras theorem, in this right triangle ACM, we'll get that AM squared, that is the square of the hypotenuse, equals to AC squared plus CM squared. AM equals to 2R, therefore AM squared is 2R squared. 2R squared is 4R squared. And it is equals to AC squared. AC is 24, therefore AC squared is 24 squared, that is 576, plus CM squared. CM is 32, therefore CM squared is 32 squared, that is 1024. So 4R squared equals to 576 plus 1024. It is in total 1600. So if I know that 4R squared equals to 1600, we divide this equation by 4, and finally we get that R squared equals to 1600 over 4 is 400. R squared equals to 400. We take out all of this equation, and we get that R equals to the square root of 400, that is 20. So the radius of this circle R is equals to 20 units in its length. Here, R equals to 20 units. In the next step, we focus on the right grand triangle AOD. I'll copy the right grand triangle AOD. We will find out the missing side OD, by implementing here the Pythagoras theorem. So I copy the right triangle AOD in the new page. AO is the radius that is equal to 20 units. The hypotenuse AD equals to 25 units. Actually, this is the right triangle AOD that I copied from the original drawing. AO equals to 20, it is the radius, and AD the hypotenuse equals to 25 units. By PT is the version for Pythagoras theorem. According to the Pythagoras theorem, in this right triangle AOD, we get that AD squared, that is the square of the hypotenuse, must be equal to AO squared plus OD squared. So AD squared, AD is 25, therefore this square is 25 squared, that is 625, and it is equals to AO squared. AO is 20, therefore AO squared is 20 squared, that is 400, plus OD squared. OD is the missing side, so we leave it as it is. We confirm and found out that 625 equals to 400 plus all this square. We'll subtract 400 from this equation, and we get that 625 minus 400 is 225 is equals to OD square. We'll take a root out of this equation and we get that OD equals to the square root of 225, that is 15. So I found out here that the missing side OD in this rectangle AOD equals to 15 units in its length. What is the area of the green shape? The area of the green shape equals to the area of the right triangle AOD that we'll define as A1 plus the area of the green triangle ACD that we'll define as A2. So in total the area of the green shape equals to A1 plus A2. I'll write it down. The area of the green shape in total is equals to A1 plus A2. A1 is the area of the right triangle AOD. So I'll copy again the right triangle AOD and we will find out the area of this right triangle. This is the right triangle AOD that I covered from the original domain. A1 is the area of this right triangle. The area of this right triangle AOD equals to OD, that is the base, times AO, that is the height, over 2. OD equals to 15, AO equals to 20, divided by 2. 15 times 20 is 300. And 300 over 2 is 150. So if we found out that A1 equals to 150 units, A1 equals to 150 square units. That is the area of the right triangle AOD. In the next step we find out the area of A2. The area of A2 is the area of the right triangle ACD. So copy the right triangle ACD in a new page and we'll find out the area of this right triangle. This is the right triangle ACD that I covered from the original domain, and A2 is the area of this right triangle. What is the area of this right triangle, triangle ACD? Is equals to the base of the triangle, that is DC, times the height of the base, that is AC, over 2. DC equals to 7, AC times AC is equals to 24 over 2. 24 over 2 is 12, so in total this expression equals to 12 times 7. 12 times 7 is 84. Found out finally that A2 equals to 84. We have already found out that A1 equals to 150 square units. Repeat again that the area of the green shape equals to A1 plus A2. A1 is 150 plus A2 is 84. 150 plus 84 equals to 234 square units. So the area of the green shape in total it is equals to 234 square units. This is the answer to the second question. This is the answer to the question according to the second method. In the next step, I will summarize the lecture. start the first method. In this lecture we found out the area of this green shape. So in the domain we have a quarter circle AOB. AOB is a quarter circle. Inside the quarter circle we have quadrilateral AODC. Our mission is to find out the area of this quadrilateral. It is the green quadrilateral AODC. In addition, we know that side AC of the quadrilateral equals to 24 units, side CD of this quadrilateral equals to 7 units, and this angle ACD equals to 90 degrees. Again, we have to find out the area of quadrilateral ACDO. It is the green quadrilateral. So, in the first method, first of all, we know that AOB is a quarter circle, therefore angle AOB, this angle equals to 90 degrees. And point O is the center of a circle that we can create by completing this quarter circle to a circle. So from point O, that is the center of the circle that we can create, we draw perpendicular on chord AC. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and AC as P. Here we have rule number 11. According to rule number 11, the perpendicular to a chord drawn from the center of the circle bisects the chord. The center of this circle is here at point O. From point O, we draw perpendicular on AB. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. So whenever I draw from the center of the circle perpendicular to a chord, like here, OM is perpendicular to AB, then OM will also bisect chord AB. That is to say, AM will be equal to MB. So whenever we draw perpendicular to a chord, that perpendicular also bisects the chord. That is to say, AM equals to MB. We can implement rule number 11 in our drawing. Why? Because in our drawing, point O is the center of the circle that we create by completing this quarter circle to a circle. From the center of the circle, we draw perpendicular called AC. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. So the perpendicular OP, according to rule number 11, also bisects chord AC. That is to say, AP equals to PC. In total, AC equals to 24. So each half must be equal to 24 over 2, that is 12. So AP is the first half, that is equal to 12 units, and PC, this is the second half, that is also equals to 12 units. Okay, this is the implementation of rule number 11 in our drawing. The next step, from point D, we do perpendicular on PO. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. In this way, we created quadrilateral PCDO, PCDQ. In this quadrilateral, we have 1, 2, 3 right angles. Therefore, the fourth angle must be equal to 90 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So in some quadrilateral PQDC we have 4 right angles, therefore quadrilateral QP is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, CD equals to PQ and rectangle PCQD. But CD equals to 7, therefore PQ must be also equal to 7. Likewise, the rectangle PCQD, side PC must be equal to the opposite side QD. But PC is 12, therefore QD must be also equal to 12. In the next step, we defined line segment QO as X. We focus on the right triangle QOD. In this right triangle, we define this again as alpha. This angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees, that is the sum of the angles in any triangle. So, this angle must be equal to 90 degrees minus alpha. But we defined 90 degrees minus alpha is beta, therefore this angle equals to beta. Then we know that angle AOB in total equals to 90 degrees. This angle is beta, so 90 degrees minus beta must be equal to the missing angle, angle POA. Again, angle AOP, it is the same, equals to 90 degrees minus beta. 90 degrees minus beta, it is 90 degrees minus beta, and beta is 90 degrees minus alpha, so we substitute beta here by 90 degrees minus alpha. Here we open the brackets. 90 degrees minus 90 degrees is 0, and minus times minus is plus. So in total this expression equals to alpha. So we found out that the missing angle, angle AOP, equals to alpha. This angle equals, we will focus on the right angle AOP. This right angle AOP, this angle equals to alpha, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus alpha. But 90 degrees minus alpha equals to beta according to our definition, therefore we substitute 90 degrees minus alpha by beta here. Then we focus on the right triangle QOD. We copy the right triangle QOD in the page, and we find out the value of triangle alpha in this triangle QOD. This is the right triangle QOD that I copied from the original drawing. Triangle QOD. OQ equals to x, according to our definition, QD equals to 12 units, and this angle QOD equals to alpha. In this right triangle QOD, we get the tangent alpha equals to OQ over QD. OQ equals to x and QD equals to 12, so in total we found out finally the tangent alpha equals to x over 12. Then we focus on the right triangle AOP, and copy the right triangle AOP in the new page, and we found out that value of tangent alpha in this right triangle also. This is the right triangle AOP that I copied from the original drawing. AP equals to 12 units in itself. What is the value of PO? Here, from the drawing, it is very easy to see that PO in total equals to PQ plus QO. So PO equals to PQ, that is 7, plus QO, that is x. So in total PO equals to x plus 7. PO equals to x plus 7, AP equals to 12, and angle POA equals to alpha. So in this right triangle, triangle APO, we will get the tangent alpha equals to AP over PO. AP is 12 and PO is x plus 7. So in total, we found out actually the tangent alpha equals to 12 over 7. Tangent alpha equals to 12 over x plus 7. So we have two different expressions for tangent alpha. According to equation number 1, tangent alpha equals to x plus x over 12, and according to this equation number 2, tangent alpha equals to 12 over x plus 7. Therefore, we created equation number 3. According to equation number 3, tangent alpha according to equation number 1 must be equal to tangent alpha according to equation number 2. Tangent alpha according to equation number 1 is x over 12, and it must be equal to tangent alpha according to equation number 2, that is 12 over x plus 7. Here we cross multiply this equation and found out that x times x plus 7 equals to 12 times 12, that is 144. Here we subtracted 144 from this, we open the brackets here. X times x plus 7 is x squared plus 7x equals to 144. We subtracted 144 from this equation, and finally we found out that x squared plus 7x minus 144 equals to 0. This is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. Here a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we will find out the value of x according to this special formula. X actually equals to minus b plus minus the square root of b squared minus 4 times ac over 2a. Here also a, b, and c are the coefficients of the quadratic equation. In our specific quadratic equation, x squared plus 7x minus 144 equals to 0, the coefficient a equals to 1, the coefficient b equals to 7 and the coefficient C equals to 144. Here A, B, C. So we put the data inside this formula for x in order to find out the value of x. Now, we'll remind you that according to our definition, the length of line segment QO equals to x. So we have to find out the value of this line segment QO. So here we put the data inside the formula for x. X equals to minus b. B is 7, so minus b is minus 7, plus minus the square root of b squared. B is 7, so b squared is 7 squared, that is 49. Minus 4 times a is 1, times c is minus 144. So in conclusion, we found out that x equals to minus 7 plus minus 4 times minus 144 is 576, and 576 plus 49 in total equals to 625. So in conclusion, we found out that inside the root we left only with 625. So x equals to minus 7 plus minus the square root of 625 over 2. The square root of 625 is 25. So in conclusion, we found out that x equals to 7 plus minus 25 over 2. Here we have two solutions that are possible for x. The first solution for x is that x equals to minus 7 minus 25 over 2. Minus 7 minus 25 is minus 32, and minus 32 over 2 is minus 16. So in conclusion, we found out that x equals to minus 16, but because of the fact that x is the length of this line segment QO, x as a length must be a positive number, so we cancel the solution that x is equals to negative number. And we left only with the only solution, the second solution that is possible for x. The second solution for x is that x equals to minus 7 plus 25 over 2. 25 minus 7 is 18, so in total this expression equals to 18 over 2, that is 9. In conclusion, we found out that x, that is the length of this line segment QO, equals to 9 units. Okay. So here, what is the area of the green shape? The area of the green shape, we divided the area of the green shape into 3 parts. The first part is the area of the right triangle APO. We defined the area of the right triangle FA1. The second part is the area of the right triangle OQD. We defined the area of the right triangle OQD as A2. And finally, the third part of the green shape is the rectangle PO, PQ, DSC. We define the area of rectangle PQDC as A3. It is obvious that the area of the green shape in total equals to A1 plus A2 plus A3. Okay, so find out each area separately, and then we'll add the 3 areas to each other. This will be the area of the green shape. So I'll repeat again, the area of the green shape equals to A1 plus A2 plus A3. A1 is the area of the right triangle APO, so I'll copy the right triangle APO from the original drawing. This is the right triangle APO that I copied from the original drawing. AP equals to 12 units in its length. PO equals to PO equals to PQ plus X. PQ is 7 and X is 9. 9 plus 7 is 16. So PO in total equals to 16 units. PO equals to 16. And the area of this right triangle APO equals to the base AP times the height, that is PO, over 2. AP is 12, PO is 16 over 2. 16 over 2 is 8, so in total this expression equals to 8 times 12. 8 times 12 is 96. So in conclusion, we found out that the area of this right triangle APO equals to 96 square units. Then we found out the area of A2. The area of A2 is the area of triangle OQP. This is the area, this is triangle OQP that I copied from the original drawing. OQ equals to 9 because it is X, and X equals to 9. QD equals to 12 units. So the area of this right triangle OQD equals to OQ, that is the base, times the height, that is QD, over 2. OQ times QD over 2. OQ is 9, QD is 12 over 2. 12 over 2 is 6. So in total this expression equals to 6 times 9, that is 54. So in conclusion, we found out that A2 in total equals to 54 square units. And finally, we found out the area of A3. A3 is the triangle, the area of triangle PCQD. The area of any triangle is the width of the triangle times the length. The width is QP times the length, that is PC. QP equals to 7, the length PC equals to 12. So in total the area of rectangle PCQD equals to 7 times 12, that is 84. That is to say A3 equals to 84 square units. Again, the area of the green shape in total equals to A1 plus A2 plus A3. A1 is 96, A2 is 54, and A3 is 84. 96 plus 54 is 150, 150 plus 84 is 234. So in conclusion, we found out that the area of the green shape equals to 234 square units. We finish with the first method. In the next step, I show to you how to find out the area of this green shape according to the second method. In the second method, we joined points A and D together by straight line. In this way, we created the right triangle ACD. Then we implemented the Pythagoras theorem on the right triangle ACD in order to find out the length of the hypotenuse AD. So this is copied the right triangle ACD. In this new page, this is the right triangle ACD that I copied, the right green triangle ACD that I copied from the original drawing. AC equals to 24 and CD equals to 7 according to what is given as the question. According to the Pythagoras theorem in this right triangle ACD, AD square equals to AC square plus CD square. So AD square equals to AC square. AC is 24, therefore AC square is 24 square, that is 576 plus CD square. CD is 7, therefore CD square is 7 square, that is 49. So in conclusion, we found out that AD square equals to 576 plus 49, that is actually 625. AD square equals to 625, we took out of this equation, and finally we found out that AD equals to the square root of 625, that is 25. So the length of the hypotenuse AD is 25. Then we completed the quarter circle to a circle. This angle equals to 90 degrees because AOB is a quarter circle, and point O is the center of this circle that we created here. Point O is the center of the circle, point A is the point of the circle itself, therefore OA is the radius of the circle. We define the radius of the circle as R. So OA equals to R. Then we extended the radius AO until it touches the circle at point M. AO or AM is a chord that passes through point O, that is the center of the circle. Any chord that passes through the center of the circle must be the diameter of the circle. Therefore, AM is the diameter of this circle. Point O is the center of the circle, point M is the point of the circle itself. Therefore, OM is also the radius of the circle, and indeed we can see that AM in total equals to R plus R, that is 2R. AM, that is the diameter of the circle, equals to 2R, of course. Then we extended the side CD by straight line until it touches the circle at point M. It is impossible that the extended side D will touch the circle at point N. Why? Because here, if the extended CD will touch the circle at point N, then we get that we have here a peripheral angle ACN that is equal to 90 degrees, and it doesn't rest on the diameter of the circle, that is AM. It rests on AN, that is not the diameter of the circle, but it must rest on AM, because it is equal to 90 degrees. It contradicts rule number 5. Therefore, we can conclude from it that the extended side D must touch the circle point M and not in any other point, and then we will not have the contradiction to rule number 5. Why? Because we have peripheral angle ACM that is equal to 90 degrees, and peripheral angle that is equal to 90 degrees indeed rests on AM, that is the diameter of the circle. Okay? So here we have CDM is a one straight line. The dominant surf is not accurate, but you should understand that CDM must be one straight line according to rule number 5. So what is the value of CDM? CDM equals to CD plus DM. Okay, but before that, we prove that those two right triangles, triangle ADO is congruent to triangle NDO. Why those two triangles can go into each other? First of all, AO equals to OM. Both are the area of the circle, therefore they are equal to each other. Okay. AO equals to OM, they are both the area of the circle, therefore they are equal to each other. If you focus on this side of the straight line AM at point O, here the sum of the angles must be equal to 180 degrees. Which angles we have here? This angle equals to 90 degrees, plus the missing angle, in total they must be equal to 180 degrees, therefore the missing angle here must be equal to 90 degrees. So both those two angles are both equal to 90 degrees, therefore they are equal to each other. I'll say it again. Angle AOD equals to angle OD, they are both equal to 90 degrees, therefore they are equal to each other. And finally, OD is a common side that belongs to both triangles, so OD equals to itself. OD equals to itself is a common side that belongs to both triangles, so we actually prove that those two right triangles can go into each other according to side angle side rule. From the fact that those two right triangles can go into each other, we derive that AD equals to DM. AD equals to DM. AD equals to DM according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles can go into each other, therefore the corresponding sides AD and DM must be also equal to each other. So AD equals to DM, but AD equals to 25. You can write here that AD equals to 25, and from this equation 25 equals to AD equals to DM, we will derive that DM also equals to 25 units. Here DM, sin DM also equals to 25 units. So in total, CM equals to CD plus DM, that is to say CM equals to CD, that is 7, plus DM, that is 25. So CM equals in total to 7 plus 25, that is 32. So then I copied the right triangle MCA in the new page and we implemented the Pythagoras theorem on this right triangle ACM. This is the right triangle ACM that I copied from the original domain. AC equals to 24 units according to what is given as the equation. We just right now found out that CM equals to 32, and we have already found out that AM is the diameter of the circle, that equals to 2R. So according to the Pythagoras theorem, in this right triangle, triangle AMC, AM square equals to AC square plus CM square. Repeat again, AM square equals to AC square plus CM square. AM is 2R, therefore AM square is 2R squared. 2R squared is 4R squared, and it is equal to AC square. AC is 24, therefore AC square is 24 squared, that is 576. Plus CM square. CM is 32, therefore CM square is 32 squared, that is 1024. So in total 4R squared equals to 576 plus 1024. 1024 plus 576 equals in total to 600. So if we found out that 4R squared equals to 600, We divided this equation by 4 and finally found out that r squared equals to 1600 over 4, that is 400. So r squared equals to 400, we took out of this equation and found out that r equals to the square root of 400, that is 20. So the radius of this circle r equals to 20 units. Okay. Then we found out the value of OD by implementing the Pythagoras theorem on this right triangle AOD. So I copied the right triangle AOD, the right triangle AOD, and we implemented on this right triangle AOD the Pythagoras theorem. This is the right triangle AOD that I copied, the right triangle AOD that I copied from the original drawing. AD is the hypotenuse that equals to 25 units, and we just right now found out that AO, that is the radius of the circle, equals to 20 units. OD is the missing side. According to the Pythagoras theorem in this right triangle AOD, AD squared equals to AO squared plus OD squared. AD is 25, therefore OD squared is 25 squared, that is 625, and it is equal to AO squared. AO is 20, therefore AO squared is 20 squared, that is 400 plus OD squared. So in conclusion, I found out that 625 equals to 400 plus OD squared. We subtracted 400 from this equation, and finally found out that OD squared equals to 625 minus 400 is 225. So 225 equals to OD squared. We took out of this equation and finally found out that OD equals to the square root of 225. The square root of 225 is 15. So finally we found out that this side OD equals to 15 units in its length. Our mission is to find out the area of the green shape. The area of the green shape equals to the area of triangle A, the right triangle AOD, that we defined as A1, plus the area of the right triangle ACD, that equals to A2. So in total, the area of this green shape equals to A1 plus A2. Repeat, the area of the green shape equals to A1 plus A2. A1 is the area of the right triangle AOD. So I copy the right triangle AOD here. The area of this right triangle AOD equals to the base OD times the height of the base, that is AO over 2. OD times AO over 2. OD is 15. AO is 12. AO is 20 over 2. So 15 times 20 is 300, and 300 over 2 is 150. So the area of this right triangle AOD, that is actually A1, is 150 square units, plus the area of the right triangle ACO. So copy the right triangle ACO here, and we found out the area of this right triangle ACO. This is A2 actually. The base CD is 7, the height AC is 24 according to what is given as the equation. So the area of this right triangle ACO equals to the base DC, that is times the height, that is AC over 2. DC is 7, AC is 24 over 2. 24 over 2 is 12, so in total this expression equals to 12 times 7. 12 times 7 is 84. So in conclusion, found out that A2 equals to 84 square units, and we have only found out that A1 equals to 150 square units. Again, in total, the area of the green shape equals to A1 plus A2. A1 equals to 150, A2 equals to 84. 150 plus 84 is 234. So in conclusion, found out that the area of this green shape, according to the second method also, equals to 234 square units. Okay, thank you very much.